This will kick off a series of videos to introduce fusion splicing and provide guidance, techniques, and tips to take you from zero to splicing in no time at all. Hopefully, this series of videos will be engaging and informative and help to demystify the intricacies of fusion splicing. A background in optical fiber is highly advantageous when approaching fusion splicing. There are many reasons why you might splice an optical fiber. It may have been damaged and need repair, or you may be building a new network. You may be terminating fiber in an MDF, an IDF, splicing curbside, and the list goes on. The key theme, of course, is joining two fibers together. So, how does fusion splicing work? It's a lot like arc welding. Not exactly, but similar. Most forms of welding use a filler rod or wire to bridge the gap between the parts being joined. Fusion splicing, on the other hand, uses an electrical arc to heat the two optical fibers above melting point to soften the two glass ends. Then, with precision electric motors, guided by image processing, push the melted fiber ends together. The arc continues until the fibers have melted together sufficiently to form a strong splice. All in all, the joining process takes only a few seconds and produces a splice with low optical power loss. Contrasted with mechanical splicing, fusion splicing eliminates the air gap, which contributes to higher optical power loss, greatly improving network link loss when several splices are present. So, before you splice, there are some things that you have to take into consideration before firing up your splicer to get going. It's important to understand what we mean when we talk about fibers and equipment being clean. There's clean, and then there's fiber clean. Because fusion splicing is such a fine-tuned process, any tiny bit of contamination can very easily cause splice defects. As you work through the process, make sure that the fibers and other surfaces are as clean as they can possibly be. The preparation procedure and order are incredibly important because any dust, dirt, debris, or oil on the bare fibers will interfere with the quality of the splice. If a fiber is contaminated pre-splice, many poor splice conditions can result. For example, if a particle of dust is on the end face of the fiber, when the fibers touch during the arc, the dust will ignite, causing a bubble when the glass melts. The presence of a bubble will cause light to be refracted or reflected by the defect, inhibiting proper signal transfer and requiring splice rework. The first step to successful splicing is to set up your machine according to the method that works best with your work style and the conditions you're working in. For this demonstration, we'll be using the universal sheath clamps that are installed in the 90S Plus from the factory. But if you prefer to splice using fiber holders, the preparation procedure is the same. Once you have your fibers in hand, slide a clean splice protection sleeve onto one of the fibers and move on to preparing your fibers to be spliced. Since such a high level of cleanliness is necessary for successful splicing, fiber needs to be prepared in a very specific order. To prepare fibers for splicing, first strip the fiber, then clean the fiber, then cleave the fiber. Don't make an additional cleaning pass after cleaving the fiber, because at this point it is perfectly clean and any dust or debris is introduced after the fact by the cleaning wipe. This strip, clean, cleave process makes sure that the mating surfaces of the two fibers are perfectly clean and that no contamination is introduced at the splice point. It may seem intuitive to clean the fiber again just to make sure. However, the newly cleaved end face has only ever touched pure glass, meaning that right after the cleave, the glass is as clean as it's ever going to be. To strip the coating from standard 250 micron coated 125 micron clad fiber, you'll most likely use a handheld stripping tool. Most stripping tools like these feature 3 holes or slots, where each slot corresponds to a different diameter of coating to be removed. For example, this pair has a slot for removing a 2 or 3 millimeter jacket, 900 micron buffer tube, and a small slot for removing 250 micron acrylate coating off of a 125 clad fiber. To strip the fiber, simply place the fiber in the appropriate groove of the handheld stripping tool, close the tool, and pull the fiber through the groove. Ideally, you'll remove 30 to 35 millimeters or about 1.5 inches of coating, although most fiber cleavers can accept a longer piece of stripped fiber than this. The longest and shortest lengths you can strip are determined by the fiber cleaver you're using. The minimum is determined by the distance across the cleaver pads. The exposed, clean glass must span completely across both pads to ensure proper cleaving. It should be even longer if it is to be pulled into a scrap collector afterwards. The maximum is determined by the size of the opening in your scrap collector. If the fiber is too long, it will not be captured properly by the collector. When removing the outer jacket from the 900 micron tight buffer fiber, it's important to know that there are 2 layers of coating over the 125 micron glass, meaning an extra stripping step is required. First, place the fiber in the 900 micron removal slot of the stripping tool and remove lengths of about 6 millimeters or 1/4 inch of jacket at a time until you reach the desired length of stripped fiber. After that, go back to the smallest hole of the stripping tool and remove the inner 250 micron coating. The 900 micron coating is very thick and firmly bonded to the inner coating, so if you try to remove the whole amount in one pass, it'll break the fiber every time. To clean the fiber, you'll need a fresh, lint-free wipe, like AFL's WFW wipes, and 99% or greater isopropyl alcohol. You'll first moisten the wipe with the alcohol, then fold the wipe in half over the fiber. Then, in one motion, you'll squeeze the fiber inside the wipe while you pull it through the alcohol-dampened wipe. Rotate the fiber by about 90 degrees and wipe again. After these 2 cleaning passes, the fiber's glass is clean and should not touch any surface other than the clean cleaver pads and blade, and also the splicer's V-grooves. To ensure that you're squeezing the fiber tight enough, listen for the characteristic squeak as the fiber slides through the wipe. This step is crucial to avoid contamination of the fiber cleaver and Fusion Splicer. Clean fiber prep tools and Fusion Splicer will enable repeatable, successful Fusion splicing for hundreds or thousands of splices, depending on how you clean your equipment. The next step is cleaving the fiber. In contrast to cutting the fiber, a cleave is a precision cracking process, leaving a pristine, flat end face on the fiber. This is a key step to splicing and is very often the deciding factor in whether or not you'll come out with a good splice result. To cleave the fiber, first raise the cleaver arm to the ready position. Next, lay the fiber across the clamp pads of the cleaver, locating the end of the color jacket at the desired cleave length marked on the ruler of the loose fiber adapter on your cleaver. You'll then close the retention clamp on the fiber adapter to hold the fiber in place for the cleave. If you're using fiber holders, you'll remove the adapter plate from the cleaver and place your fiber holder into the slot, taking care to avoid placing it on top of the fiber holder spacer. Then, with one hand steadying the cleaver, use the finger of your other hand to gently lower and close the cleaver arm, being sure to press down from the middle at the end of the cleaver arm. After the cleave, open the retention clamp and place the fiber directly into the splicer before returning the cleaver arm to the ready position. This ensures that the cleaver blade doesn't brush against the newly cleaved end face of the fiber as it returns to its original position. When everything is working properly, the cleaving process leaves a clean, flat, and smooth end face on the freshly cleaved fiber. However, everything doesn't always work the way it's supposed to. Many times, a dirty, oily, or dusty fiber is cleaved, transferring whatever contaminants were on the fiber onto the cleaving pads onto the cleaver blade. This is incredibly important to be mindful of because any contamination will compromise the cleaver pad's ability to hold the fiber in place. If the pads can't hold the fiber completely still, then the fiber will move irregularly during the cleave, causing an angled cleave, a ripped cleave, or no cleave at all. A good rule of thumb for developing fiber prep habits is that nothing should touch the fiber after it's been cleaned, except the cleaver pads and the splicer's V-grooves. The opposite is also true. Nothing should ever touch the cleaver pads, cleaver blade, or splicer V-grooves except a clean fiber. If conditions allow, we even recommend washing your hands prior to fusion splicing. Once your fiber is prepared, carefully lay it in the V-grooves of your splicer. If you're using sheath clamps, make sure the end face of the fiber is located roughly halfway between the V-grooves and the center line between the electrodes of the splicer. If you're using fiber holders, the spacing is already set by the cleaver's fiber holder slot and the fiber holder pins in the splicer. At this point, you're ready to splice. Select a splice mode according to the fiber that you're using and follow the splicer's prompts to finish the splice. Be sure to select the splice mode corresponding to the fiber type that you're using. Different fiber types have different internal structures, meaning that each combination will require a unique splicing recipe. The mode which splices multi-mode to itself is much different from the mode splicing single mode to itself. If you use the wrong splice mode, the fibers might melt together, but the splice will be either weak or the core will have diffused too much to maintain its function as an optical waveguide. The 90S Plus comes equipped with the auto mode, which manages all these complexities for you, so you can rest assured that any fiber type differences will be accounted for by the splicer. Once the splice is finished, center the splice protector over the exposed glass and hold tension on the fiber while you lower it into the heater oven. Glass has a very high tensile strength, so don't be shy with holding tension on your splice. If you're using the sheath clamps with your splicer, it's incredibly easy to center the sleeve over the splice point. Simply grab one side of the fiber at the edge of the sheath clamp, lift out of the splicer, and tilt until the sleeve stops against your finger. The sleeve is now centered, so you're ready to lower it into the heat oven. As you lower the splice into the oven, the fibers will press down on activation switches, and the heater oven will close over the sleeve and shrink it. When the heater opens, remove the protected splice and you're ready to splice again. Fusion splicing has come a long way since it was invented and has grown to a well-established technology, enabling the expansion of networks and expanding the availability of high-speed data connection to more people than ever before. If you have questions about your splicer, want help walking through the splicing process, or have a need for detailed technical support, don't hesitate to call the 24/7 365 helpline at 1-800-235-3423, option 3.